Hi, I'm Dacia Cipher, and I'm going to demonstrate how to compute a Pearson R using SPSS. As you see, I have a data set in SPSS displayed that is the data set called Exercise 28, Example 1. Now, these data are data from veterans with a type of inflammatory bowel disease called ulcerative colitis. These two variables are BMI and the patient's age at the initial diagnosis of UC. And as you know, BMI is a measure of body fat based on height and weight. And the null hypothesis is that there is no correlation between age at a diagnosis and BMI among veterans with ulcerative colitis. Now, this is a smaller data set because the data set in the book has you compute the Pearson R by hand as well. And I try to keep those data pretty short, pretty brief, so that you can manage them in your hand calculations. In reality, this data set was much larger, and the power of statistical procedures is addressed in both exercises 24 and 25 in your Grove Cipher textbook. A few assumptions that the Pearson R needs for it to be a valid statistic for your data are addressed also in the book, but a few are really important. And one of them is the scale of measurement. Generally, we like to have at least interval or ratio scales of measurement for your variables, but ordinal data are also acceptable as long as higher numbers mean more of something, lower numbers represent less of something, and that goes hand in hand with the distribution of the variable. Especially if it's Likert scale, it really does need to be an approximately normally distributed variable. So a pretty easy way to check the normality of your variable is also addressed in exercise 26. We're going to check it out by going to Analyze, Descriptive Statistics, and Explore. We're going to move over our two variables into the dependent list and click on Plots and Normality Plots with Tests. Click Continue and OK. And what we're going to be looking for is one table. And that table is the test of normality table. And as you can see, we are looking at a table with both variables and two tests of normality in one table. One, the Kolmogorov-Smirnov, is for very large samples over 1,000. Obviously, our sample size is only consists of only 20 veterans, so we're looking at the Shapiro-Wilk test. And the significance column in the last column is for both of these, we have p-values that are greater than 0.05, indicating that both variables actually do meet criteria for a normal distribution. And this test is presented in more detail in exercise 26, but here we know that these two variables are approximately normally distributed and meet that assumption, at least for the Pearson R. So let's go into that menu. We'll go to Analyze, Correlate, Bivariate. We're going to highlight BMI and age and move them over. And Pearson is a default here, so we don't have to do anything else. Click OK. Let's take a look at the output here. What we see here is a table. It's a sort of matrix to where the upper diagonal is a mirror of the lower diagonal. So there's a lot of redundant information in this output, but you can see the important pieces. The important pieces are the Pearson R is 0.462. And this has an asterisk by it because it's considered significant at an alpha of 0.05. So SPSS flagged the correlation. Same information above as well. And the p-value, the exact p-value is 0.041. Actually, there are a lot of decimals after that. If you double click into the table and double click again, you can see that the numbers can actually go on, but we just report 3 decimals. So the exact likelihood of this Pearson R being 0.46, if the null were actually true, is only 4.1%. So we consider this significant at the 0.05 level. And so we also know, we notice that the R is a positive value, not a negative value. So a positive R indicates that higher numbers of one variable are associated with higher numbers of the other variable. If it were an inverse correlation, that R would be negative, meaning higher values of one value are associated with lower values of the other value. So it's positive. So we're ready to interpret our Pearson R. And the interpretation, as we might say it in APA format, is a Pearson correlation analysis indicated there was a significant correlation between BMI and age at diagnosis among veterans with UC. R, degrees of freedom equals 18 equals 0.46, P equals 0.041. Therefore, higher BMI values were associated with older ages at which the diagnosis occurred. I hope this helps, and thanks for watching.